Title page, Vectors, by Donovan Blackman and Seth Baker. Vector. We all know that classic character from Despicable Me. You know, the weird short dude in an orange jumpsuit with the weird bowl cut and the glasses? Well, when he says, I'm applying for a villain mode, I go by Vector. It's a mathematical term represented by an arrow with both direction and magnitude. Vector! That's me, because I commit crimes with both direction and magnitude. Oh yeah! Well, surprisingly, when Vector says that he commits crime with both direction and magnitude, he has a point. Vectors, as you said, both have direction and magnitude. Magnitude is also known as a scalar, or how much of something there is, like a measurement between point A and point B. It is a quantity, but it has no direction. The difference between a vector and a scalar is that a vector has direction. Vectors overall also do not change based on perspective. Vectors are used in geometry and physics for both its directional and magnitude properties. One example includes the situation of Donovan and Seth moving a math table for Mr. Schmidt. He wants them to move it 3 steps forward and 3 steps to the right. This creates a vector as it has both a quantity or magnitude and direction. These are your workers represented by the graph seen here. Although in Seth's point of view, he is moving it to the right 3 steps and moving it forward 3 steps. It may not be what Donovan thinks he's doing. If Donovan is picking up the table from the opposite side of Seth, Donovan would be moving 3 steps to the left and 3 steps backwards. Even though these are all different directions, they are still going to the same place. If we were to plot both of these movements or vectors on a graph, we would see the things that are expressed on this graph. But these graphs are nothing without context. So when we write them out and label the axes appropriately, or axes, we see that these movements are in fact the same because they not only have the distance/magnitude, but they have the needed direction. Let's look at this in another light. Check out this graph and the equation that follows it. As you can see, the vector is represented as 3x weird cone shape and 3y weird cone shape, showing the distance each point is going on the graph. While the next graph represents another perspective of negative 3x weird cone shape prime and negative 3y cone shape prime. But as you can tell once again from this example, they are going the same direction and distance because, once again, vectors still don't get no perspectives. With both vectors and scalars, there's another topic that takes both of these into account, called tensors. These two ideas are part of the tensor family, and there's even another topic that is the result of vectors having orientation, called stress. But that is not the point. The point is that vectors, scalars, and stress create tensors. Tensors are used in everyday life for things that even draw images in your brain. Airplanes also use vectors, as they go to a location in a direct path and not in squiggly lines and etc. There are so many examples that are used in everyday life that we can't list them all off in this video. But without vectors, none of this would be possible. And I don't know about you, but vectors seem to be pretty cool. We chose this topic partly because we just wanted to pick something and get it done, but also because we wanted to see the history of our boy Vector from Despicable Me, and what his name really means. We wanted to explore why vectors are so important, and how when different forces or information is presented, how that affects the outcomes. We discovered that vectors are both direction and magnitude, giving a specific measurement combined with the direction to create a vector. These, along with their counterparts, scalars, which are just purely measurements such as distance, volume, weight, etc., are part of the bigger group of tensors, which are vital aspects in the world around us.